Good morning students. Today we are going to discuss about superconductor and its applications. Superconductivity is the important phenomena which was discovered by the Kamerlingh 1 in 1911. What is superconductivity? That is important phenomena. We want to know about the phenomena. Superconductivity means zero resistance property. Certain material possess zero resistance when you can reduce the temperature to absolute zero level and below that. It means at certain lower temperature the property of the superconducting materials fully act as a conductor and it loses its resistance. So that is why we call certain materials or zero resistance material. Just you can see what is the difference between the non-superconducting metal and superconductor. Just you can see the temperature of the certain material you can decrease towards 0 Kelvin. When it reaches the lowest temperature, it means the critical temperature. At that state, this normal state of the material changes into superconducting state. When you can say the certain material which does not possess superconducting property, that even you can reduce the temperature to 0 Kelvin, it will not possess superconducting behavior. So here you can see there is a two region is existing. One is the superconducting region and this region is act as the normal conducting region. For example, you can say mercury. So what is the mercury? Mercury is nothing but a metal which is liquid in state. What is the temperature here? The temperature mentioned here as a 4.2 Kelvin is the critical temperature. So this critical temperature is the temperature at which this mercury will act as a superconductor. So above 4.2 Kelvin, this mercury becomes a normal conductor, and below 4.2 Kelvin, this mercury is act as a superconductor. So now what has happened? What is the main property belongs to superconductor? Because when the material possesses zero resistance means the electrons are freely moving within that region. So that is the main important property. There is no resistance and there is no loss because of the collision of the electrons exists in such a type of material. So that is the peculiar advantage. Now we go for the next factor is an effect of magnetic field. So now one factor is according to the temperature. We are telling that when you can decrease the temperature from the higher order to the lower level, it means up to the critical level, you can say that the certain material loses its normal state and normal property and it becomes a superconductor. And at the same time, you can say the superconductivity will disappear if the temperature of the specimen is raised above its critical temperature. So that is the reversible process. When you can decrease the temperature, that normal conductor will become a superconductor. When you can increase the temperature, that superconductor become a normal conductor. So this is a reversible process. And another factor, this superconducting behavior can be followed and explained on the basis of zero magnetic field. So because when you are increasing the magnetic field, that will also make a disturbance and it will not support for the superconducting behavior, and then certain material loses its property when you are increasing the magnetic field. So the critical value of the applied magnetic field is necessary to restore the normal resistivity. So normally we are using the one parameter is the temperature. So reducing the temperature to the lower level, that is the one factor. When you can take the another parameter is the magnetic field. So when you are taking the magnetic field as a tool, when you are increasing the magnetic field, at that time there is a chance of increase in normal behavior rather than the superconducting behavior. That is the one important factor. Next. So, whenever you can go to know about the superconducting material, the Meissner effect is the main important phenomena. So, what happens when you can see that blue ball is indicating that as a superconducting material? When the temperature is very greater than the critical temperature, when you can apply the magnetic field, the magnetic flux line penetrates the superconducting material. So, when the temperature is very less than the critical temperature, now the magnetic flux lines are pushed out, and that means ejecting out. The magnetic flux lines are not penetrating and it is going out of the superconducting material. So, the superconducting material does not allow the magnetic flux line into the material. So, that phenomena is called as Meissner effect. So, why such a behavior exists? When you can take the flux at the transient temperature is ejected due to the induction of the current in the specimen, while produces a flux equal and opposite to the original flux due to the magnetic field. So, I want to explain here, right? Just you can take a superconducting material. So, superconducting material consists of more electrons. These electrons are called as super electrons. So, when the density of the super electrons are more in the case of superconducting material, at the same time the flow of super electron creates a induction current. So, that induction current flow creates a magnetic flux. That is why there is an opposite magnetic flux developed in the superconducting material, and at the same time this flux opposes the original flux which we applied. Since in the superconducting state the resistance is 0, the current due to the induction in the specimen persists as long as field is on. So, how long this current will persist, how long this flux will be pushed off, that is important. When you can switch on the field up to that extent, these flux lines are moving away only because of the flow of electrons inside the material is accelerated, and also this electron creates the flow of electron creates the magnetic flux. That flux line opposes the applied magnetic field. So, due to this persistent current, specimen acquires a negative moment, producing a field in direction opposite to the direction of the applied field. So, the specimen behaves diamagnetic. So, what happens here? When you are applying the magnetic field, at the same time there is an opposite flux generated by the superconducting material and it opposes the applied field. That is why we call that as negative magnetic moment. So, this magnetic moment creates the diamagnetic behavior. So, whenever you can say the superconducting material possesses diamagnetic property. When you can remove the external field, so persistent current goes off. So, there is no continuity of current will be exist in the material. As soon as switch off the field, there is no persistence of current exists. Now, we can classify this superconductor into two types, such as type 1 superconductors and type 2 superconductors. Type 1 superconductors normally we call that as soft superconductors, and then it has no mixed state. It exhibits complete Meissner effect. So, just you can see when you can apply magnetic field, you can apply the magnetic field, the induced magnetic field goes on increases. When it reaches the critical field Hc, suddenly drops down. This means rapidly comes down and then it becomes a normal state. So, within this superconducting state, there is an increase in magnetic moment. According to the Meissner effect, I told you that the magnetization is increases because of the superelectron's presence. And then it creates the superconductivity between the 0 to Hc, that means a critical field. Above the critical field, that material becomes normal state. So, when you can consider the type 1 superconductor, there is two states, one as normal state, other one as superconducting state exists. Next is the type 2 superconductor. Here you can see the type 2 superconductor does not exhibit complete Masonry effect, and there is a gradual loss of magnetization, and it will consist of mixed state, otherwise you call that as a vertex state. So, when you can take the type 2 superconductor, type 2 superconductor consists of 3 states, one as normal state, mixed state, and finally superconducting state. And when you can see the critical field for the type 2 superconductor, there is a 2 critical fields exist in the case of type 2 superconductor. So, when you can say the Hc1 is the lower critical field, below the lower critical field this material is act as a superconductor, and in between the critical fields Hc1 and Hc2 it acts as a mixed state, or you call that as a vertex state. After Hc2, that means higher critical field, this material fully becomes a normal material, or you can say that as a state is normal state. So, what are the applications of these superconductors? So, based on the peculiar property of the superconducting nature of the material, the superconducting magnets have been used to levitate the train above the rails. So, first is the magnetic levitation. Because of the peculiar properties of superconducting material, we have to use this superconducting material for electric power transmission line. So, what happens? Because there is no resistance, so the electrons can move freely from one place to the another place. So, that is why during the power transmission we can avoid useless radiations and heat. Next one, you can use this type of superconducting material in the case of electric generator. There is the generator will be reduces its size and weight, and it consumes very low energy. So, that while using this type of electric generator, we can suggest that it is an energy saving power system. Next one, this superconducting material is used for ore separation. So, because of the magnetic property of the superconducting material, the ores present in the earth that can be separated with the help of superconducting magnets. And also one of the main advantageous application is the separating the tumor cells from healthy cells. Finally, we go for the very good large scale application of superconducting material as magnetic levitation. As we know very well about the poles of the magnet. So, opposite poles attract each other, same pole repulse each other. So, now we can take the force of repulsion, but the force of repulsion is existed in the normal magnet, but the phenomena will be the similar, but it is not so in the case of magnetic levitations occur in the case of superconducting material. So, superconducting magnets have been used to levitate the train above its rails, drive it at a great speed with a minimal expenditure of energy. So, this is the magnetic levitated train. So, look at here, so many vehicles are moving or floating over the supermagnets. So, this is one of the view of the superconducting trains. So, now this is the arrangement of the supermagnetic phenomena exist in the vehicle. The Professor Ingan Chen from Taiwan, he has explained how the superconducting magnet will be and how it is working. So, this circular disc is nothing but a superconductor. Look at here how this vehicle is floating over the rails with the phenomena of magnetic levitation. Now, we have to define the characteristics Masonry effect.